Good afternoon, and welcome to our fifth Touro College and University System New York Medical College webinar on the COVID-19 pandemic. Yes, our fifth. We gathered for the first time at the end of January, but it seems like a different world, doesn't it? At that time, we gathered in person in a lecture hall at one of the Touro buildings in Manhattan. We were there in person as speakers, and the audience was there in person. But now it's no longer January. It's no longer a situation where, as we heard in January, we listened to a parade of speakers from the public health department saying, it's gonna be fine. We have everything under control. We have a terrific infrastructure to deal with what may come our way from this virus from China. How wrong that turned out to be. And now it's August and we're on our fifth webinar/seminar on the pandemic. And every time we conclude one of these, I think to myself, maybe this is going to be the last one. But every time I've been wrong, so we're back again. We're back again for those of you who have been with us for previous seminars and webinars. We're back again with a new cast of characters. You're going to see some old faces and a lot of new faces this time. We've drawn upon speakers not only from New York Medical College this time, but from the Touro College of Osteopathic Medicine in New York and from the Touro College of Osteopathic Medicine in Vallejo, California. We have learned through this pandemic of the fearsome mortality and morbidity consequences of the pandemic and of the devastating economic consequences. And we hope through the conveying information to you, we will help those of you helping to care for patients with COVID-19 and those of you managing your own institutions and public health responses. We hope through the information we convey today that we will help you do your jobs better and in a more informed way. Now, we have chosen for this webinar not to have people send in their questions for the question and answer period in advance. Instead, we'll take your questions live by you going on your screen and going to that place on your screen where it says Q&A. You go ahead and type your questions in throughout the webinar. We'll be monitoring them. And then when we get to the question and answer period, Dr. Alan Kadish, the president of the Touro College and University System, will be the question and answer period moderator. He will read the questions and invite individual members of our panel to respond. So whether you wish to state your name or ask the question anonymously, you go ahead. And as I said, we'll monitor them and we'll do as many as we can when we get to the question and answer period. I am always asked to tell people who are interested in CME credit how to file for their CME credit. And it seems like no matter how many times I do it, someone says it's not enough. So I'm going to appear on the screen now and 3 more times during the webinar to tell you how to get your CME credit. You either text the code 06 capital S, capital I, capital P, capital E to 828-295-1144, or you go on the website to www.eeds.com, click the sign-in button, and type in that same code 06 in all capitals SIPE, and then you will start getting messages or email messages or instructions how to step-by-step sign up for your CME credit and answer the questionnaire about your satisfaction with the webinar. May I suggest that you either write the instructions down or do a screenshot, or perhaps take out your cell phone and take a picture of the screen now so you have the information. Well, everyone, welcome to our webinar, and we'll begin with our first speaker. Thanks for joining us, and I'll see you again later in the meeting to repeat the CME instructions.
Hi, this is Dr. Alan Kadish, President of the Trudeau College and University System and President of New York Medical College. Welcome to the 5th New York Medical College Trudeau Symposium on the COVID-19 pandemic. Boy, it's been a wild ride since our first symposium in late January. COVID has been devastating. Well over 100,000 people have died in the United States, and millions have become sick. Similar catastrophes have occurred throughout the world. But it's been more than the health issues. COVID has been devastating economically, socially, and practically to many people's lives. Lockdowns have been difficult, and fear of infection has been paralyzing for many. Entire industries have been completely disrupted. Even education, which has been relatively well protected, is going through a major disruption. Just in the past week, some schools have decided to play football and some have not. Some that had previously said they would open are now not going to open except virtually. And we continue to struggle to try to react to a changing environment where COVID remains completely unpredictable. We've learned a lot about COVID in the last few months, and we hope to tell you a bit about that today. Unlike some other cases where we've had the luxury of working out extensive basic science before we begin therapeutics or clinical trials, the devastation of COVID has led us to conduct therapeutic trials and the development of a vaccine at breakneck speed without waiting for the basic science and biology to be fully understood. We're still struggling with exactly how COVID spreads, but several drugs have been shown to be effective, at least in the most severe patients with COVID. However, we still lack a drug that's safe and effective at preventing early infection from making people ill. Vaccine development has also occurred at a breakneck speed. Several vaccines are currently in phase 3 trials, including some that are quite promising. Vaccines are being developed that work in different ways, raising the possibility that one of those approaches will be effective. The time course of development of these vaccines has been amazing. A process that used to take 5 to 10 years has been truncated in what we hope will be 12 to 18 months. That's been both exciting, but created some issues. The need to rapidly develop therapy and vaccines and clinical information has exacerbated the problem of scientific fraud. The careful debate and careful analysis review process have in some cases been short-circuited to try to get information to people quickly. And that's resulted in some well-publicized cases of fraud. Today, we won't continue to focus on the biology, but we will continue to talk about what we've learned about how COVID may affect several vulnerable populations. We know COVID has certain effects on the elderly with a higher mortality. We used to think that children were well protected. Now it may be that they're only relatively protected. And people with underlying diseases and certain racial and ethnic groups are at higher risk. So today we'll hear a little bit about the clinical aspects of COVID in different populations, some of the drugs that have been shown to be effective at treating COVID, and the approaches to vaccine development. We're not there yet at licking COVID, but we hope that with the dedication of scientists throughout the world and the application of resources, as well as the exciting scientific environment which COVID arose in, where we know a lot more than we did even a decade ago, that the attempts at therapy and vaccine development will soon be successful, and that we can quickly return to a more normal way of living, even though COVID in some way may be with us for quite a while. Welcome again. Thank you for coming today.
Hello, my name is Dr. Michael Clearfield, and I am Dean of Touro University College of Osteopathic Medicine in California. And I will be discussing for the next few minutes the potential influences of the COCCI syndemic on the COVID-19 pandemic. I have no conflicts of interest to declare. Now, one may ask, how did this topic evolve? Well, it came from asking two questions that had been asked and continue to be asked about COVID pandemic. Why do some people get the disease while others don't, given that they have the same or similar risk profiles? And the second question is, why do some people get very sick or die while others have little or no symptoms given similar exposure? I will propose three hints as to how and why this may occur. The first hint lies in the common risk factors for COVID. These were first noted in China and then moved to Europe and the United States. What do these have in common? Cardiovascular disease. In fact, cardiovascular disease itself is a risk factor for COVID. However, two of these risk factors, obesity and metabolic syndrome, will factor in as foundational for this presentation. On this slide, we look at central fat around our organs and within the liver. This can represent inflamed adipocytes that may induce a systemic oxidative stress, resulting in a dysmetabolic state, cytokine expression, and cellular inflammation. A second risk factor is air pollution and climate change. The particulate matter that we'll focus in on for this presentation is the fine particles, 2.5 microns or less, that originate mostly from combustion. These particles, when inhaled, can go into the lung, depositing in the alveoli, and potentially then move into the pulmonary circulation and then eventually the systemic circulation. The other particulate matter for this discussion comes through the turbulent gas cloud that occurs when we sneeze, we cough, or even talking. This produces large viral droplets that are greater than 10 microns, which tend to settle faster than they evaporate, thus contaminating the immediate vicinity, which is generally within a 2-meter area or about 6 feet, the area of our recommended social distancing. On the other hand, a sneeze or a cough can also produce smaller droplets that can rapidly evaporate or form residual particles such as droplet nuclei or aerosols. These smaller particles can travel much further due to the velocity, humidity, or airspeed, or sometimes if they can hitch a ride onto a particulate matter of 2.5 microns or less. The first study that looked at this to try to connect particulate matter with COVID viral particles was done in Lombardy, Italy. This is an area that has a high level of pollution, but also had a high level of COVID mortality. And the study suggested that long-term exposure to particulate matter may well be a cofactor for high COVID mortality. Another study from the Harvard School of Public Health found a strong association between particulate matter and COVID mortality in 3,000 counties spread across the United States. This study demonstrated that a 1 microgram per meter cubed increase in particulate matter was associated with a 15% increase in COVID mortality. Thus, a small increase in long-term exposure of particulate matter in a newly infected COVID individual could potentially increase the all-cause mortality by up to 20-fold. Now here's a map, and this map represents the particulate matter in the United States prior to COVID. Notice the hot zones in red. This next map represents COVID at the beginning of the pandemic in the United States, around March 27th. This was generally before there was wide-scale social distancing, face masks, or quarantine. Again, notice the distribution of the hotspots. This next slide combines the two, showing very similar distribution of particulate matter and COVID viral particles. Which brings us to our third hint, why particulate matter and COVID might be bad together. This slide is a little complicated, but if we follow it and show the particulate matter in light blue, they induce a pulmonary oxidative stress and inflammation, and how it can spill into the systemic circulation, inducing this pro-inflammatory state, promoting cardiovascular disease. While in yellow, we find obesity, which follows a similar path with similar results. So as an analogy, if you consider central obesity as a hot ember, simmering subclinically in our body, awaiting for another stimuli, here comes particulate matter, augmenting and enhancing the same atherosclerotic risks. It's like putting kerosene on the embers. Now we create a flame. Such a flame as the atherosclerotic system is now figuratively burning. which now brings us to the concept of the syndemic. For those of you unfamiliar with this term, a syndemic consists of at least two different diseases or contributors to disease and the social and environmental factors that promote and enhance their adverse outcomes. In this case, we combine the dysmetabolic obesity and air pollution climate change, resulting in worse cardiovascular outcomes than would be expected by either alone and even together. This is the COCCI syndemic, which stands for cardiovascular disease as a cause for obesity, climate change, as a cause of obesity, climate change, and inflammation. When COVID droplets are added to the COCCI syndemic risk factors, it can supercharge the ember and the flame into a cytokine firestorm, enhancing susceptibility to the virus and increasing the inflammatory response potentially up to 20-fold. So, to answer the two questions that were originally asked, adding COVID-19 to the COCCI syndemic may turn a mild or asymptomatic case into an ICU-bound medical catastrophe by supercharging the dysmetabolic state, the cytokine expression, and the cell inflammation. Likewise, when a COCCI individual is exposed to COVID, their ability to ward off infection may be severely compromised. That, in part, may explain why some people get the disease and others do not. Given COVID has been with us for about 9 months, but has spawned over 38,000 articles, there's obviously a lot more that can be said, but I'll leave you with this quote from Ralph Waldo Emerson: "The sun will eventually shine after every storm." Thank you for your attention.
Hello. Today I'm going to be talking about kids and COVID-19 and the impacts this pandemic has on our children. My name is Dr. Tammy Hendricks. I'm a pediatrician and the Associate Dean of Academic Affairs at Touro University, California, College of Osteopathic Medicine. I have nothing to disclose for this presentation. The first impact we think of when we think about children and COVID-19 is the fact that kids can become sick. We know that children have lower rates of incidences of COVID-19. As of July, children under the age of 18 account for about 7% of all COVID-19 cases in the United States, about 1% of all COVID-19 hospitalizations, and less than 1% of all COVID-19 deaths. COVID-19 does have some other serious ramifications in children. We see multi-system inflammatory syndrome in children, or MIS-C, in kids who have COVID. MIS-C is a condition in which different body parts can become inflamed, including the heart, lungs, kidneys, brain, skin, eyes, and gastrointestinal organs. MIS-C can be serious and even deadly, although most children who are diagnosed with it have gotten better with good medical care. As of August 6th of this year, the CDC has reported 570 cases of MIS-C related to COVID-19 here in the United States. That's been spread across 40 states and has contributed to 10 deaths. Experts estimate that the global total of COVID-19 deaths could eventually reach 10 to 40 million, which will inevitably leave many children without one or both parents or caregivers. Orphan children are particularly vulnerable to trafficking and other exploitation. Older children often drop out of school to try to support younger children. Stay-at-home and shelter-in-place orders have resulted in declines in outpatient pediatric visits and fewer vaccine doses being administered, leaving children at risk of catching vaccine-preventable diseases. In this chart here, we can see the rates of immunizations here in the United States. We can see when COVID-19 really became rampant in the US, about halfway through March, and that rapid decline of childhood immunization rates as shelter-in-place and stay-at-home orders began. This chart only goes through April, but we have seen these trends continue. The American Academy of Pediatrics and other expert groups have repeatedly stated that schools are fundamental for child and adolescent development and well-being, and provide our children and adolescents not only with academic instruction, but also with social and emotional skills, safety, reliable nutrition, physical, speech, and mental health therapy, opportunities for physical activity, among many other benefits. Beyond supporting the educational development of children and adolescents, schools play a critical role in addressing racial and social inequity. We have seen with this COVID-19 pandemic, worldwide school closures. This chart here shows us the number of countries that have had localized school closures, the number of countries where the entire country has closed down schools, and also the number of countries, the very few number of countries who have remained open for their schools. As of August 2nd of this year, we have seen that over 1 billion learners have been impacted by school closures. 60.5% of total enrolled learners have had this impact, and there are 106 country-wide closures of schools. Lockdowns and shelter-in-place orders, along with lack of access to school and childcare, come with a heightened risk of children witnessing or suffering from violence and abuse. This is increased with the economic downturn, loss of jobs, and increased household stressors. Rising malnutrition is expected in children who normally rely on school meals as their reliable source of daily nutrition, and they're now left to look for other sources. Here in the United States, the National School Lunch Program provides low-cost or free lunches for 29.7 million children a day. That number of children may be at risk for looking for where they're going to find their next nutritious meal. Now more than ever, children and their families are turning to digital solutions to support children's learning, socialization, and play. Internet usage is up by 50%. Children are now at greater risk of online harms, such as sexual exploitation and cyberbullying. They're at risk of stumbling across potentially harmful content online, and they're at risk of the inappropriate collection, use, and sharing of their data. Finally, during the extent of this pandemic, we have continued to see increased rates of depression, anxiety, stress, and isolation in children of all ages. So what can we do to help protect kids in the setting of a pandemic? First and foremost, we must continue to practice our safety measures to try to decrease the incidences of COVID-19. So wearing our face masks, making sure we're practicing good social distancing, washing our hands, staying at home when we're sick. We need to encourage children and their families to continue with preventative care, continue to see their pediatricians for the well child visits, continue to stay up to date with their childhood immunizations. We need to ensure there's adequate support for schools and safe education so that the teachers and the children are protected and can attend school in person. We need to ensure equity of access for childcare and support services, regardless of socioeconomic status. Secure those food supply chains so that we continue to deliver nutritious meals to the children who need it most. We need to educate children and their families about the risks of being online and ensuring that they have adequate online safety. And then finally, making sure that we have increased access to good mental health services for children of all ages. Together, we'll be able to get through all of this. Thank you so very much for listening.
Hello again. This is Dr. Edward Halperin, your host for our webinar on COVID-19. For those of you who want to ask questions, please go ahead on your computer, go to the Q&A function on the bottom and type your question in. We're monitoring your questions, and we will get to as many questions as we possibly can during the question and answer period. For those of you who want to know how to sign up for your CME credit, here's the information a second time. Text the code 06SIPE to 828-295-1144, or type into your browser www.eeds.com and type in the same code, and you'll start getting instructions as to how to get your CME credit and how to fill out the questionnaire regarding your satisfaction with our webinar and any suggestions for future webinars.
Hi everyone, my name is Tianchun Wang. I'm Associate Professor of Pharmacology at Toro-Com. Today I'm going to talk about the role of dexamethasone in COVID-19 patients. I have no conflicts of interest to declare in this presentation. Corticosteroids has a long history being used in severe acute respiratory syndrome. In 2003 SARS infection, there are 4 case reports, all 4 reports showing that patients who use corticosteroids has more likely harmful effect than benefits. Some of the patients suffers from severe side effects, most likely due to the high dose of corticosteroids they've been using. In 2012 MERS infection, there is a clinical trial showing that 150 patients who receive corticosteroids has no difference in the mortality rate, but more likely a harmful effect due to the delayed viral clearance. In the current pandemic for COVID-19, there are 2 clinical trials reported using corticosteroids. Both shows benefits effect. Today, we're going to talk about a large clinical trial that's using dexamethasone, which shows a beneficial effect to certain COVID-19 patients. As we know that dexamethasone is a very potent glucocorticoid. This clinical trial is called Recovery. It is a large, controlled, open-label, and multi-arm clinical trial designed to evaluate the effect of dexamethasone and other potential treatments in the hospitalized patients with COVID-19. A total of more than 2,000 patients are enrolled in the dexamethasone arm, and more than 4,000 patients are enrolled in the control arm. Patients receive oral or IV dexamethasone at 6 milligrams per day, and this is considered a medium dose of dexamethasone and up to 10 days. The preliminary endpoint analysis is a mortality rate at 28 days. Let's look at what conclusions we can get from this clinical trial. Overall, dexamethasone significantly lowers the mortality rate in COVID-19 patients. If you look at the figure here, on figure A, the x-axis is the date of treatment, and the y-axis is the mortality rate. The black curves here is a patient who receive usual care as a control, and the red curves here is a patient that received dexamethasone treatment. The dexamethasone group has a mortality rate of 22.9%, while the usual care has a mortality rate of 25%. This may not be as big as a difference as you imagine, but it is a significant decrease. Now, I think what is more informative are conclusion 2 and 3. And the second conclusion, they found out that the patient who receive respiratory support is at the time of the randomization, especially those who receive invasive mechanical ventilations, those patients benefit most from dexamethasone treatment. If you look at figure B here, again, the black curve is a patient that's using the usual care, and the red curve is a patient that's using dexamethasone. For those ventilized patients who you receive usual care, the mortality rate is 41.4%. But for the patients who receive dexamethasone in this group, they have a death rate of 29.3%. And this is a very significant difference. Even for the patient who do not need mechanical ventilations, they just receive the oxygen support. those patients still benefit from dexamethasone treatment. However, for the patients who do not need any respiratory support at the time of randomization, those patients do not benefit from dexamethasone treatment at all, and maybe even worse with dexamethasone treatment. Well, the next conclusion, they found out that patients with a longer duration of the symptoms benefits more from dexamethasone than those who has just been diagnosed. If you look at this chi-square test for trend, pay attention to the patients who receive dexamethasone at more than 7 days of their symptom onset. Those patients has lower mortality rate and also benefits more than this group, the patient who received dexamethasone at shorter than 7 days of their symptoms onset. So to conclude, the great physician Paracelsus used to say that the effect of a substance depends on the dose that the person receives. In terms of dexamethasone, we should probably modify this statement into the effect of dexamethasone treatment in the COVID-19 patients really depends on the dose, the time, and who received the treatments. More specifically, the date, the right dose is about the medium dose of dexamethasone, 6 milligrams per day. And the right patient are the patients who are hospitalized while receiving the respiratory support, either oxygen or mechanical ventilations. In another word, more severely ill patients. The timing, the patients who have symptoms more than 7 days when they receive dexamethasone seems to benefit more from the treatment. Now the take-home message is, what are the mechanisms? So for COVID-19, similar to the other severe viral pneumonias, that they believe, they hypothesize that the lung damage in the later stage of the infection are most likely due to the host immune response rather than the viral itself. Dexamethasone, as a very potent glucocorticoid, inhibits the immune response and protects the lung. The significance of this trial is quite remarkable. This is such a big trial and put together in such a short time, and while during a pandemic, and still yield very informative informations. And the other significance about this trial is that dexamethasone or the other glucocorticoids are really cheap and have global accessibilities. Well, of course, there's a limitation for this trial. For example, they do not report secondary point analysis. They do not test this drug in certain patient populations, and they do not test remdesivir at the same time with dexamethasone. With that, conclude the presentation for today. I will see you at the Q&A session. Thank you.
Hello, my name is Kathleen DiCaprio. I'm an assistant professor of microbiology and immunology at Touro College of Osteopathic Medicine in Harlem, New York. My talk today will be on COVID-19 vaccine development. I have no conflicts of interest to declare. So here we are, August 2020, months into an historical pandemic. There is a global race for COVID-19 vaccines. The World Health Organization lists approximately 29 candidate vaccines that are in various stages of clinical trials and regulatory processes across the globe. For my talk today, I'm going to be discussing the landscape of vaccine development in the United States with a focus on the top vaccine candidates. I'll also briefly explain Operation Warp Speed, partnership among various components of health and human services for mass acceleration and production of a safe and efficacious vaccine, maintaining safety standards throughout. So what do we know about the vaccine candidates? When we look at the candidates, they fall into one of four platforms. We have mRNA in lipid nanoparticles. We have non-replicating adenoviral vectors. We have inactivated virions, and we have recombinant protein subunit vaccines. Now, the details of these vaccines are a bit complex and beyond the scope of our talk today. I simply want to highlight these to show that they do induce and activate appropriate immune cells, ultimately activating a SARS coronavirus 2 specific immune response. Now, the target proteins of all of these vaccines are similar, mostly focusing on various aspects of the spike protein. So, once a vaccine is developed, it needs to go through clinical trial phases to look at 3 outcomes or findings. The safety outcome identifies adverse events and optimal dosing. The immunogenicity outcome identifies aspects of the vaccine-induced antiviral response, immune response. Now, both safety and immunogenicity outcomes are pivotal and necessary in phase 1, phase 2. With promising early data, a vaccine can then move into phase 3. Phase 3 is where we assess for efficacy. We're also going to have a larger group of participants. Efficacy findings tell us if and how well a vaccine is able to provide protection against COVID-19. Phase 3 data is critical for vaccine approval and approval for public use. Now, clinical trials are time-consuming, and availability of new vaccines can take months, years after approval, depending on available resources. Operation Warp Speed has established strategies with developers to mass produce candidates with the most promising phase 1 and phase 2 data before phase 3 has concluded. This way, if the vaccine is deemed safe and efficacious through phase 3, large quantities of the vaccine can be available for quick and immediate dissemination, at least quicker than normal. So let's take a look at the vaccine candidates, starting with those in the nucleic acid platform. We have one vaccine developed by Moderna and NIAID, and another BioNTech, Fosun Pharma, and Pfizer. Now, the vaccine schedules for both of these include 2 doses, each dose separated by about 3 or 4 weeks. Both have moved mostly through phase 1 and phase 2, showing promising and acceptable safety and immunogenicity data. They both have had similar adverse events that are minimal and short-term, like pain at the injection site, fever, fatigue, and the immunogenicity data has shown good cellular and neutralizing antibody responses. Both have recently moved into phase 3, and efficacy is being assessed. So the data over the next few months should tell us how protective these vaccines are against COVID-19. Next, we have the non-replicating adenoviral vectors. We have one from the University of Oxford, AstraZeneca, and Janssen Pharma with Johnson & Johnson. Both have also demonstrated acceptable and promising safety immunogenicity data. The data is similar to the data we've seen with the mRNA vaccines, minimal adverse effects, good cellular and neutralizing antibody responses. Now, if we take a look at these vaccines, though, and you look at the schedule, you'll see they both have 2 dose schedules. However, the Johnson & Johnson vaccine is also assessing a single dose. This one will be interesting to follow as it moves into phase 3. Finally, we have an inactivated vaccine from Sinovac and a protein subunit vaccine from Novavax. Both of these vaccines, just like the other ones, have shown promising and acceptable safety and immunogenicity outcomes. Sinovac vaccine is ready for phase 3, and the Novavax vaccine hopefully will be moving into phase 3 soon. As a conclusion to the presentation, I want to show how the phases of these vaccines align with their projected timelines. So using the present time, August 2020 as our starting point, Moderna, Pfizer, and AstraZeneca have vaccines furthest along in the clinical trials with projected and much anticipated initial efficacy data hopefully coming out in fall of 2020. Now, for the Sinovac, Novavax, Johnson & Johnson vaccine, those vaccines are a little bit further behind the other ones, moving into phase 3 soon. Hopefully, we're going to be getting those initial efficacy data later in fall of 2020. Now, for the 3 vaccines on the bottom, we hope that promising and acceptable safety, immunogenicity, and efficacy data will lead to FDA and regulatory approval, hoping for fall of 2020, probably earlier 2021. Now, this is where Operation Warp Speed partnerships hope that their efforts pay off, because by supporting aspects of mass production and resource availability earlier in clinical trials, the goal is to have larger quantities of the approved, safe, and efficacious vaccine available and ready for quick dissemination. These timelines, they can't be guaranteed, but we can only hope. In the meantime, just sit back, wait, do it with a mask, of course. Thank you. Here are my references for those that are interested.
Good afternoon. I'm Dr. Fred Bierman, DIO and Director of Graduate Medical Education at Westchester Medical Center and Senior Associate Dean and Professor of Pediatrics at New York Medical College. In March of 2020, COVID-19, the novel coronavirus variant, began its clinical surge to the greater metropolitan New York region, extending into New Jersey, Connecticut, and Massachusetts. As hospital operations strove to implement informed responses to the pandemic, respected clinical investigators sought insights to inform therapies that would mitigate the morbidity and mortality of COVID-19 infection. To that purpose, 2 publications co-authored by the same investigators were released. One in The Lancet, addressing the use of hydroxychloroquine and chloroquine, the other in the New England Journal of Medicine, addressing cardiovascular disease, drug therapy, and mortality in COVID-19. Based on a single observational international database, de-identified for source and patient, those publications offered therapeutic guidance to the medical communities impacted by the COVID-19 surge. The publications were initially accepted by the medical community. The publications became part of a unique churning of medical and political debate. As the pandemic challenged medical therapeutics and hospital operations, increasing attention was given to the publications. Their initial acceptance interrupted other investigation of COVID-19 therapeutics. And then the spotlight of scientific scrutiny was focused on the data source and analytics on which the publication's conclusions were based. By early June, the increased scrutiny by the scientific community led to requests for audit of the collaborative registry's source documents. As reported in the New York Times 2 months after the initial publication of the manuscripts, the collaborative registry would not comply with the audit of the data on almost 100,000 COVID-19 infected patients treated in over 600 hospitals across 6 continents. By report, the lead authors acknowledged they had not reviewed the raw data on which their publications were based. The author, whose data analytics registry procured, organized, and analyzed the raw data, refused to participate in the requested audit. The Lancet responded with an extraordinary expression of concern that was published in June, less than 1 month after the publication of the 2 articles. By the end of July, both articles were retracted. The discussion in the medical community was robust and quite agitated. Why did these publications transition from revelation to reservation and ultimately retraction? The July 28th New York Times investigative report focused on individual accountability, an accountability that in graduate medical education is the foundation of professionalism. The accountability of the single author who is the steward of a now unverifiable multinational registry that circumvented the guardrails of scientific veracity and appears to have breached the professionalism expected in the medical community. The Times article reflected on the graduate medical education experience of the investigator in question. Those reporters interviewed colleagues and mentors of the individual during residency training. They reflected on his record. His record was remarkable. He had a college degree at the age of 19, medical school graduate with a PhD by age 27. He completed training. He was described as very bright, very quick, an entrepreneur with an MBA and a prolific research experience. They also noted, however, that he was willing to cut corners and misrepresent information or embellish his credentials. In fact, his resident colleagues reported they couldn't trust what he said, and it became standard practice to double-check anything he reported. During his training, there were questions about whether or not he should be graduated to the next level. One physician, who was his mentor, reported that the physician could be abrasive. He had worked on papers with that young physician, and he was convinced that the complaints by others were driven by personality differences and professional jealousy, not substantive deficiencies in skill or patient care. Instead of failing the physician in question, he was given an opportunity to work on his professionalism and interpersonal skills. It was noted that the individual said it was his life's work to build a company that could provide life-saving clinical insights to make the world a better place. It remains to be determined what will be the outcome of the investigation of the registry that that physician was the steward of and upon which those two manuscripts were published. In the graduate medical education community, professionalism is foundational. It is also extremely difficult to define. Professionalism, from my perspective, is really self-regulated conduct that is consistent with established expectations. In our context, it's established expectations in the medical community. But then what is conduct? Conduct is character operationalized. Then what is character? Character is a composite of our learned experiences. When we learn those experiences varies from individual, varies between professional responsibilities. And it is our ability in the graduate medical education community to focus on those character traits that will provide a conduct that operationalizes those character traits that allow us to participate in a manner of professionalism that is self-regulated and consistent with established expectations. In doing that, however, we cannot nullify creativity. People cannot simply function within boundaries to achieve professionalism. We have to preserve creativity while we do provide standards of expectation. We have to be cautious with innovation. This experience with the two publications occurred with the novel introduction of large data analytics that are centralized and de-identified. They cross international boundaries. They cross institutions. We have to be prepared to deal with how we use that type of data. One of the classic experiences of disruptive innovation took place on October 30th, 1938, when Orson Welles did his famous War of the Worlds broadcast on radio. Radio was a new technology. And when people tuned in, to his broadcast and did not hear the initial disclaimer, they thought the Martians had landed in New Jersey. Just as the lessons learned with the War of the Worlds, we have to be diligent in how we integrate our disruptive innovations into our medical community, into our graduate medical education enterprise, and into our expectations for professionalism.
Thank you, Dr. Bierman, for that interesting presentation. Hello again, everyone. This is your host, Dr. Edward Halperin, and I hope you've enjoyed our presentations by our panelists. It will soon be time for the question and answer period. If you have not typed your questions in yet, go on your screen to the Q&A function on the bottom, click on it, and go ahead and type your questions in. And our moderator for the question and answer period, Dr. Alan Kadish, will be looking at your questions and will pose them to our panelists. There are always people who want to know how to get their CME credit. And I am now showing for the third time the way to do that. Text the code 06SIPE to 828-295-1144, or type in your browser www.eeds.com and then click on the sign in button and put that same code in. And whether you use the text message system or you use the EEDS website, you'll start getting instructions as to how to get your CME credit and how to fill out the questionnaire regarding your satisfaction with the meeting. May I suggest that you either write these instructions down, do a screenshot, or take your cell phone and take a picture of the screen, so you will have these instructions. Now it's time for our question and answer period, and we'll be joined by Dr. Alan Kadish, the president of the Touro College and University System, who will be our moderator for the question and answer period. Hope you're enjoying the webinar, and I'll see you one last time at the end of our session.
Thank you very much, Dr. Halperin. There have been a lot of very interesting questions that have come through. And I'm going to begin first with a question for Dr. Clearfield about coagulopathy and clot formation during COVID. It seems that a lot of the disease morbidity in the COVID pandemic has been caused by clot formation. Do you have any thoughts about current recommendations for preventing clot formation and how you're approaching patients?
Well, no, that goes beyond my area of expertise somewhat, but I can tell you relative to what this discussion was about, when you look at the particulate matter in the atmosphere, it seems to share a common bond along with the COVID viral particle in that it can induce a prothrombotic effect. So to prevent the thrombosis, once it occurs, there's a cascade of events that seems to be procoagulative that can affect that, including platelet adherence, hyperaggregability, etc. So I would say that anybody who has the disease, they should be aware of this as a potential complication. Obviously, if you're sick enough to go into the hospital, there'll be preventative procedures that will be done from coagulopathy perspective or prothrombotic. But to do something on a preventative basis, I'm not aware of any literature out there right now that's shown anything definitively that would allow you to reduce the risk other than what you would do for a normal person that was at high risk for any type of thrombotic event. So it's usually antiplatelet and that type of thing, antithrombotics.
Great. One other quick question for Dr. Clearfield. There was a question, particularly perhaps from a resident, about New Mexico, where there appears to be a relatively lower incidence of COVID, but a suspicion that there are some areas with high pollution. Do you have any thoughts about that in terms of your hypothesis about particulate matter and COVID rates?
Yeah, I think expanding it even beyond New Mexico is probably appropriate. But anywhere where there seems to be a lot of particulate matter in particular, might have an increased risk for inducing a hyperinflammatory response. So what makes the most sense to me in looking at this moving forward, since we don't have definitive answers on any of this, would be to usually the preventative mechanisms. You might be a little heightened in areas where somebody's at risk. They could be elderly, they could have underlying atherosclerotic disease, etc. So that there you would want them to watch even closer, to do the appropriate distancing, wear the masks, isolate themselves, and potentially modify some other things such as diet and exercise programs that we know can improve their overall or decrease their overall risk relative to potentially this virus particle and or the underlying, what we call the COCCI syndemic, which is cardiovascular disease as a result of fat that's usually visceral type fat, plus air pollution exposure or exposure to these small particulate matter.
That's great, thank you.
Sure.
There actually, not surprisingly, are a bunch of questions about vaccines that I'm going to turn to Dr. DiCaprio for. The first one is the question about vaccine development, which is the listener concluded from your presentation that most of the vaccines were developed in commercial rather than academic laboratories. And first, can you elaborate on that? And second, are there any lessons to be learned from that? And the second question was, what are your thoughts about the Russian vaccine?
Thank you. Those are great questions. The vaccines there are over 30 vaccines worldwide. And so many of these vaccines are at some level being developed at academic centers across the globe. The ones that I spoke about in the presentation, the AstraZeneca vaccine does have a strong collaborative effort with the Oxford University. So that is one that does have a tie with an academic center. Something to keep in mind with a lot of these vaccines, especially the four primary ones that I spoke about, was that they're classical vaccine technologies. So a lot of these technologies have been purchased and they're proprietary for various pharma and pharmaceutical companies that have had them in place. They've perfected them, or at least tried, and certain components of the vaccines have gone through various stages of clinical trials in other vaccines. So the biggest one we have is the mRNA vaccine, and that one is the newest. And so that is one that the technology is new, and more pharmaceutical companies are working on that one with some academic centers. But there are many, and we'll just have to see how they go. But eventually those vaccines do go to pharma companies because they do purchase a patent, and they'll move forward with those to ensure quality and mass production with quality ingredients and components. Now, the Russian vaccine is an interesting question, and I think whoever asked that question, I didn't have time to talk about it in my presentation because it's definitely something I personally am following, as I'm sure many of you are as well. It's an interesting situation because we really just don't know. There is a lot of missing safety data, and that's really what it comes down to at this point. What we do know about the vaccine is that it is composed of two different adenovirus vaccines. Now, I did speak about adenovirus. So that platform is one that is a common platform that we see with the vaccines that we're moving forward in the United States. But this one uses two different strains, both of which have shown interesting safety data in other vaccines. But as far as that clinical trial goes, we just don't have the safety data for, which is why most in the United States and elsewhere across the globe, it's a bit skeptical. I hope that answers your question.
I think that's very helpful. There are now a series of questions about what happens when we have a vaccine. So this is also for Dr. DiCaprio.
Okay, I'll stay on.
Yeah. The first question is, how long will it take? You alluded to this in your presentation a bit. How long will it take to get enough vaccine to deliver to most people or to everyone?
Oh, that's the $1 million question, maybe the $1 billion question, because that seems to be the amount of money that we seem to be going forward with contracts for every pharmaceutical company. It's very difficult to answer that question because getting the vaccine to the people who need it is a very challenging question. We've never had something like this before, this type of pandemic. So everything that we're going through on multiple levels is new. A lot of efforts and money and collaborative, are taking place, and not just in the United States, but globally. And so it is anticipated, on a very hopeful note here, that one or two vaccines will be approved late 2020, early 2021. Now that is still the game plan that we're hearing, and where the data is sitting right now at the early stages of phase 3. The next couple of months may change that timeline, but then from there, it really depends on how they can disseminate those vaccines. They can triage who is going to be the priority demographics for that vaccine. And part of that data will come from phase 3 when we look at safety. So we unfortunately are just going to have to wait to see, but hopefully early 2021 we'll start to get a good, hopefully start to get something disseminated out to people who need it the most.
And a couple of special population questions about vaccines, and then we'll let some other people talk and give you a bit of a break. If you have antibodies already, would you recommend taking the vaccine? And well, let's start with that one.
Sure, that's a great question, and that really just comes down to personal preference. That will be an interesting piece of data that's gathered from phase 3, because right now what we're doing is the inclusion criteria for the vaccine trials is to not have had COVID before. But what we're going to find with these efficacy studies is that people are going to start vaccines, or they're going to be enrolled in the trial, and then they might get them. There's going to be some overlap as we move through. That's why phase 3 is so long. So we're going to start to see if it's efficacious to do that, and that hopefully those guidelines will come out as we get more data.
Okay, let's take a break on vaccines for a couple of minutes. Quick question for Dr. Bierman, a couple of questions for Dr. Bierman. One relates to the specific topic of your presentation regarding these retracted papers. Are there things such as free availability of manuscripts and a change in the way reviews are done that might have affected the fact that these papers were accepted? You talked a lot about professional responsibility and the residency training piece of it, and that was fascinating. But what about the review process or free access to articles? Do you think either of those things had a significant impact on the fact that these papers, which seem not to be valid, were published in 2 of the leading journals in the world?
I think their review process was the customary peer review. I believe that they were credible reviews. However, you cannot escape COVID. And I think that there was perhaps a rush in expectations. And this was work by very credible authors, not the individual in question, but the senior author of the paper certainly had extraordinary scientific credibility. I think this reflects the I can't even say the word, how politics has intruded itself into the whole discussion about COVID. And it was a report that if you did not scrutinize the raw data, it appeared to make sense. The problem was at the very basic foundation of the data set. It appears the data set didn't exist, or at least it was not procured as it was suggested. This was a desire for everybody, the investigators, the reviewers, the journals, to give the public, I believe, conclusions that they could understand, not necessarily the answers they wanted, but some conclusions they could understand. And the consequence was a lack of credibility.
You mentioned politics, so tell me how you think politics might have had something to do with this.
It was very hard during, I would say, April and May, to not hear discussions about the chloroquine therapies for COVID, with opinions offered by the medical community, the other basic science community, and then the political community. And it was distracting. It is not how we customarily approach our clinical and scientific discussion. Our discourse, I think, was just simply distracted by a political overlay. It was totally unnecessary.
Thank you. We've now got a couple of questions for Dr. Hendricks. If she's available to pop on.
I am.
That's great. So there have been several questions asked in various forms about reopening K through 12 schools. There have been a couple about universities as well, and maybe I'll touch on those after you're done. But there have been several questions about, should we open schools? How do we open them safely? And then what's the relative impact on the risk of COVID if we reopen schools versus the risk of isolation if we leave children at home. So what's your take on reopening schools? As you know, New York City has a very different approach at this point, at least as of today, from a lot of large cities. So what do you feel about that? Can we do it safely? Should we do it? And what's the impact on children going to be?
Yeah, absolutely. Those are great questions. And any of us that have school-age kids, those are questions that keep us up at night as we try to decide, should we send our kids to school or should we not send them back to school? There are so many factors that go into what children get out of school, whether it's safety from their home, whether it's good nutrition, all of the social-emotional growth that school provides for children that can be more challenging in online settings. I think the decision of whether or not children should go back to school really has to depend on the safety of the individual environment. So out here in California, we're seeing the number of cases increase dramatically, so much so that all of our schools are now online for school-age children, whereas in New York, you're seeing something that's very different. And so I think taking into account those two different scenarios and what the incidence of the cases are is very important. As we look to global references, so looking at countries that were able to decrease the number of cases of COVID-19 in their environment and reopen schools, we saw some of them were able to do it very successfully, and some of them reopened schools only to close down schools again when the cases started coming back up. So in some ways, we have the fortunate advantage of being able to learn from what others are doing. And then I saw in the chat somebody was asking for some specific references, and that's the other very fortunate advantage that we have is there's so many experts that are working together to help put together guidance on these very challenging decisions. One of my favorites is a compilation that Massachusetts General Hospital put together that really puts together all of the latest research and recommendations. And so I put that link in the chat. But the American Academy of Pediatrics and the CDC also have recommendations and guidelines on to how to safely open school or what to do if you can't safely open schools. Thank you.
A related question to school opening, Dr. Hendricks, is what about the commuting, both for students and faculty? How risky is commuting? Is there a way to make commuting safer? And how should that impact our decision about opening?
Yeah, absolutely. I think any type of potential exposure and commuting, if you're commuting on public transport versus commuting in a private car versus commuting on a school bus, all of those carry different levels of risk. And so our whole goal is to try to mitigate as much risk as possible. So if the public transport, then certainly trying to make sure that you have your facial coverings and making sure you're wiping down surfaces, using hand sanitizer, maintaining social distancing. And if those things can't be maintained, then you may decide that you can't mitigate enough risk and commuting is causing more risk than it's worth.
Okay, I'll just take a moment to talk a little bit about opening colleges and universities. The best way to describe what's happened and the challenges that have been faced is it's been a bit of a nightmare. Many colleges and universities announced plans weeks ago to open or not to open. And there's been a steady trend, both in terms of in-person classes, dormitories, and college athletics, of withdrawing from opening plans. I think the causes have been a fewfold. One is, of course, in places outside the New York metropolitan area, there's been in the past month, although it may be flattening a little bit, an increase in the incidence of COVID. Second, when some schools have tried to open, such as most recently this week, UNC, University of North Carolina, students have not followed social distancing guidelines, and there have been outbreaks with significant numbers of students developing COVID and many more requiring quarantine, which has made it difficult to stay open. Finally, employees have had a significant say, and there are many colleges and universities where faculty have said, regardless of what may be best for the students, we don't want to take the risk of coming in. So we've gone from a situation where most college and universities were saying that they would be open in some fashion to a rapid back off from that plan. And I think the message is that COVID continues to surprise us. Many of the things that we thought even a month or two ago about COVID have been wrong. A very quiet situation with very few cases of COVID can explode rapidly, perhaps because of super spreaders. And in other cases, the incidence of COVID, with appropriate following guidelines, can decrease pretty quickly. So we have to be flexible. And I think that's the approach most recently the colleges and universities have adopted, is making plans either to be fully online or to be hybrid with some small on-the-ground presence or a moderate on-the-ground presence, but recognizing that circumstances, quarantines, increased incidence of COVID, change in underlying infection rates may have to result in last-minute changes. It's been tough for students who don't know what to expect, but collectively, I think higher educational institutions have been doing the best they can in a rapidly changing environment. I would say the only mistake that's been made is that there's some people who've claimed to know what's going to happen or to know for sure what's going to be safe. And I think COVID has taught us that that's a mistake, because things will change rapidly and we can't necessarily expect that we're going to be able to know what will be true even 2 weeks from now, when the school year usually starts in September. We have a question or two for Dr. Wang. The first is, in the dexamethasone studies, were there any adverse effects with dexamethasone that should give us pause about using it? So Dr. Wang, you available to get on to first answer that?
Yes, hi. So for the dexamethasone trial, the report, the preliminary report, does not talk about the side effects profile. As for glucocorticoid treatment in general, the side effects really decided by the dose and the length of the treatment. I mean, even though the report itself did not talk about the side effect, there are some similar treatment with similar doses. For example, the other clinical trial we mentioned early on that used methylprednisolone, another glucocorticoid with similar doses in a small trial. That trial also shows a benefit effect, but the side effects they reported from that clinical trial, the major one is hyperglycemia. And also with previous SARS similar type of infections, they treated with glucocorticoids, which with much higher doses. Some other major side effects are the psychosis and avascular bone necrosis. Those are more severe side effects, most likely due to the higher doses. So I would expect some of the side effects with this dexamethasone treatment, but probably less severe compared with the previous treatment with other SARS due to the doses.
Thank you. Either Dr. Wang or Dr. Hendricks, because the outbreak started in China, there was a specific question about whether either of you know what China is doing about K-12 education.
Well, my information, for what I heard, is that when they started the pandemic, it was early in the year. I think it was in January. At that time, it was the winter break for most of the K-12 students. So the school are in recess ever since that time. They got the pandemic well controlled, I think somewhere in May, late April, May, or June. Some of the school had students back to school at that time. And then there's a point outbreak in some of the cities. When that happens, and the school is immediately go to the recess again. But I think they were, as far as I know, they're expecting, most of the cities, they are expecting a full school year in the fall.
Thank you. So we actually have a couple of questions for Dr. Halperin. One is about medical student education. Dr. Halperin is the chancellor of New York Medical College, former dean at Louisville, and so he's had a long history in medical education. So the question for Dr. Halperin about medical education is, what do you think the impact of the COVID disruptions has been on medical education? Will the students who had to be removed from rotations and now are going back to a more mixed experience, will that impact their long-term? ability to function as physicians because of proficiency in training?
Thank you for the question. There have been a national profound impact on medical education because of the pandemic. We have a medical education system which is on a very strictly regulated treadmill with very little time set aside for any interruptions. Because in general, medical students on clinical clerkships were pulled from their clerkships at the onset of the pandemic in the Northeast in March, several months were lost for face-to-face clinical education. And while enormous efforts were made to try to make up for some of that time lost with virtual education, robotic simulations, and computer modeling, there's nothing that can substitute for face-to-face patient education. Those medical schools which were able to return to face-to-face clinical education this summer in July and August are likely to be able to graduate their students on time in the spring. But if there is a second wave, a further disruption, then it is hard to imagine that we will be able to graduate students in a timely fashion in 2021 if we face another major disruption. Many people have tried to point out the example of World War II and how, because of the need for doctors in the military, most US medical schools went to a 3-year program, and there were not long-term harms to medical care from these 3-year graduates as compared to 4-year graduates. There's a very big but for anyone who wants to cite that data, and that was in the 1940s, the medical school curriculum was specifically redone to cram things into 3 years rather than 4 years, and there was no disruption of face-to-face patient contact for clinical education in the 1940s, as has been produced by the COVID epidemic. So the answer to the question is there have been severe disruptions. I believe we will weather the storm if we do not face a second wave, but if we do, all bets are off.
The second question for Dr. Halperin. Even though we didn't specifically talk about it today, there have been several questions that have come up about testing. Testing in the United States has been challenging. In some ways, we seem to be behind other countries, and we still don't seem to have a consistent approach. So can you give a brief summary about where we stand with testing and what your recommendations would be for either symptomatic or asymptomatic people at this point?
Well, the premise of the question is quite true. We are, as a nation, behind in testing an instance compared to other economically developed countries. It is an illustration, perhaps, that centralized management of a pandemic is better than decentralized management, and those countries which have a centralized health system have done better at coordination of testing and contact tracing than decentralized countries. An excellent example of high penetrance of testing with excellent follow-up was Germany, in which the testing was widespread, driven by academics, with a scientist/politician chancellor reassuring the public of the importance of testing and importance of follow-up. Now, the question asks why and what can be done about it. This is a question which is a combination of science, politics, and sociology. We had multiple tests on the market simultaneously. The tests on the market varied in false positive and false negative rates. The capability of laboratories to process the test in some areas was overwhelmed. State regulations about who was authorized to process the testing slowed down testing analysis. And while there was an initial rush of people to line up in their automobiles to get tested, we now see in some places where the pandemic is striking hard, empty tents with no people lined up in cars, because it takes so long to get a result that people feel that it's not worth going to get tested. What does the future hold? Well, we're pleased to see that there are now trials underway of saliva-based testing as opposed to nasal swabs. These have been reported in the popular press, and if these prove to be useful with a low false positive, false negative rate, they may create a more efficient system. Obviously, Americans are getting used to saliva testing by mailing in their testing for 23andMe and other such saliva-based testing, so it's a less invasive testing process. Finally, Dr. Kadish asked me to comment overall on testing guidelines. Testing is mandated by some employers and by some universities before entering the workforce, both initially and on a regular basis. For those individuals who it is not mandated, testing is being recommended for those who have symptoms which are indicative of possible COVID-19 infection. Most infectious disease experts are not recommending testing of asymptomatic individuals or people who have had contact with asymptomatic carriers.
Thank you, Dr. Halperin. A couple of questions, again, for Dr. Wang, if he can get back on.
Yes.
Aside from dexamethasone, are there other drugs that have been shown to be effective in treating COVID-19?
Okay, so when we talk about the recovery trial, the one that tests dexamethasone, we talk about it's a multi-arm clinical trial. So they enroll around 3,000 patients testing other arms. The other drug get tested, several other drugs get tested. So hydroxychloroquine is one of them. That arm being stopped because it's not effective. And there are two antiviral drugs also being stopped. And the one that is still being tested in are the azithromycin, antibiotics, and tocilizumab, interleukin-6 monoclonal antibody, and the plasma from the recovered patient. Those are the trials still going on right now. As for the results, we already have, there are two drugs. Dexamethasone is the one that we talked about. The other drug you probably heard about is remdesivir. Remdesivir is also, the clinical trial also shows that that drug is good for the patients who are more severely ill, means the patients who are hospitalized and need oxygen support at least. For those who are hospitalized but moderate or mild severe, or the patient who are not hospitalized, there are no effective treatment so far.
Then there is the obvious question about what's referred to by a couple of the questioners as the Zelenko protocol, which is a combination of hydroxychloroquine, azithromycin, and zinc. Are there randomized trials, and what's your thought overall about whether hydroxychloroquine has any effectiveness?
Well, the trials so far reported there is no effect of hydroxychloroquine itself. I mean, some reports showing that the small trials or small clinical reports showing that they use hydroxychloroquine with azithromycin and zinc together. Those three drugs together showing some small scales of effective in the patients. It's hard to say because those are, a lot of them are not controlled trials. It's hard to interpret the data based on what they've been doing. A theory behind this was that the hydroxychloroquine itself is not the one that's actually effective. The effective effect is helping to get zinc or the combination with the azithromycin together. So again, those are the trials with not well controlled, and it's hard to tell if those effects are really true or not true, but the trials they've been testing about hydroxychloroquine with this large clinical trial shows no effect, and they have already stopped the trial with that.
Thank you. So now back to Dr. Clearfield for a moment, if he's still with us. We can put him on.
I am here.
Okay, so there's a question, Mike, you spoke very eloquently about particulate matter and the potential synergistic risk with COVID. What about smoking and nicotine? What do we know about those risks, and is there a benefit of nicotine potentially?
I've heard no benefit from it. I know that when you're looking at, obviously from a cardiovascular risk, obviously smoking is not good. It's a risk factor. So when you add this in and looking at cardiovascular disease as a risk factor for COVID, I can't envision how that could be good. And, they're talking about, the vapor type things too. And we know that these things can cause a pro-inflammatory response within the pulmonary vasculature, which then could possibly augment the ability for the viral particle to get more systemic quicker. So I would envision that these are not only not beneficial, but could be very harmful. Although I don't know of any study that's looked at that specifically. It's just looking at it from the other perspective of when you're looking at heart disease and smoking, we know that that's a risk factor. And since heart disease is a risk factor for COVID, it would make sense that smoking would not be of benefit to anybody.
So there's a question which maybe perhaps both of us can answer, Mike, about whether asymptomatic individuals can get heart disease, presumably asymptomatic except for any cardiac symptoms from COVID. There have been a number of reports of myocarditis in young athletes. My impression is that some of them don't have other prominent COVID symptoms, and that myocarditis has been the main symptom in at least a very small minority of those student athletes, although I don't think we really understand the full incidence yet. You want to comment on that at all?
Well, I guess the question is, what is truly asymptomatic? Because we know that there are individuals, for example, that are normal weight but dysmetabolic. And if you don't test for that, they might not have any overt symptoms. And a lot of atherosclerosis, a subclinical inflammatory response within the vasculature, where outside, if you do not manifest any specific symptoms, but you do have this low-grade inflammatory process going on. Then when you add this other aspect to it, it exacerbates that problem. So a lot of these low-risk people, and this is the same thing with a lot of the cholesterol trials, et cetera, where you have these residual effects. You treat their lipids down as low as they can, you get their blood pressure controlled, their glucose controlled, yet they still have events, even in a primary prevention mode. Why is that? Well, there's other risk factors that I could look at, and these are some of the risk factors were discussed in this presentation of having this inflammatory fat that's within your body that's causing something that is quite abnormal, but you don't have any symptoms from it. And then that gets re-exacerbated, or it gets exacerbated by particulate matter and or now the COVID viral bacteria. So I think that a lot of symptomatic people are not truly asymptomatic. You just haven't tested the right thing yet.
Got it. And one last question. There was a question about cannabis or marijuana smoking. Do you know about any data about that?
Nothing particular to this. Again, it can cause an inflammatory reaction in the pulmonary vasculature. So just like any other inhaler, there's a potential risk with that. Whether there's a benefit from it, I don't know. So I have no further information. I don't know if that's been looked at least to my knowledge, I have no information on that one.
That's great. I'd like to thank the audience for some great questions. It's now 2:28. We're going to try to finish at 2:30. And particularly the panel, who's done a just absolutely fantastic job at presenting and in answering some tough and timely questions, because there really is a lot we still don't know. We're only about 8 to 9 months into knowing anything about COVID. We've learned a lot. And some of the questions that have been difficult to get definitive answers to are because our current state, 8 to 9 months into the pandemic, is such that there's still a ton about COVID that we don't know. I think we're going to turn it back over to Dr. Halperin for one last message about CME. Wish you all a good day. Stay healthy, follow the guidelines, and we'll be back in touch when anything else is new.
Thank you, Dr. Kadish. I hope that everyone found this a useful webinar. The way things are going, I guess it's fair to say we'll be back with you again in about a month to 6 weeks with the next one in our series. And for those of you who have not been listening or writing down that number to text for your CME credit, it's 828-295-1144. And to that number, 828-295-1144, text the code 06 and then all capital letters SIPE. And in about 5 minutes, you'll get a text message back in response, and we'll give you instructions as to how to get your CME credit, and how to fill out the questionnaire regarding your satisfaction with today's webinar. We wish everyone a good afternoon and hope that you stay safe and that you'll join us again next time. Thanks for joining us this afternoon and take care. Bye-bye.